everyone. I'm Erica Stanley, and I am bringing you a recording of a talk that I gave at All Things Open this year, back in October. If you haven't heard of All Things Open or you haven't had the pleasure of attending, I believe it's the largest open source conference in the US. And the team there, Todd, Danny, and crew, do such a great job with this event. I always have a great time, meet brilliant people, and learn so much. And so thank you to Todd, Danny, and crew for inviting me, for having me, and for putting on a great event once again. When I gave the talk, I was in one of the rooms that wasn't recorded. And since then, I've gotten questions and feedback and comments over social media and in DMs. And I thought it'd be a good idea to distill that, put all of this into a recording and share it with folks. So that's what we're doing today. Let's jump right into it. I've had a long career in tech. It's been a bit of a journey. And through all of it, I've seen firsthand how the things we build have these ripple effects on society and our planet. It's really pushed me to look for a better way, a way to balance our drive to innovate with a responsibility to create a positive impact. And so that's what we're going to dig into here, how a growing movement in AI might just help us do that. We're going to discuss building our open source small language model toolbox for performance, privacy, and the planet. And before we get too far into it, I want to share all the ways that you can chat with me and each other about this recording. I keep it pretty simple. I'm just Erica Stanley on most platforms, and I've listed up top here Blue Sky and LinkedIn where I'm most active. I'm not super active on Twitter these days, but if you are and you want to reach out to me there, just let me know and I'll be sure to check and connect. From the earliest moment getting involved in tech, I was always really interested in this intersection between technology and society. So even more than just the curiosity and the discovery and the challenge and the puzzle solving and problem solving that I get a lot of reward and joy out of from tech. Even more than that, what has always fascinated me has been that intersection. So this continual cycle of us responding to technology and changing our interaction patterns, and then changing how we interact with each other, and then changing the technology, and kind of having this cycle of co-evolution of these technologies and our interaction patterns and co-evolving together. And I'm especially fascinated by it as it relates to emerging technology. So that's really how I started my career. And so to help you envision how my trajectory throughout my career has helped me become more and more aware of the impact of the technologies we've built, I thought I'd go through a really quick timeline. And as tech has grown up, as my career has matured, so have these emerging technologies over time. I started out really interested in mixed reality. This was at a time when mixed reality was not understood by the public. So it wasn't at a time where I could come home and talk about the technologies I worked in and the work that I did and have folks actually understand me. It was at a time where you had a huge room full of all of these wires and sensors and all of these things connected to a huge, very heavy headset. So not super user-friendly, but at the early stages of this technology. And I did that work during undergrad at Clark Atlanta University. I did a lot of that work at Caltech, and then continued it into my graduate program at UNC Chapel Hill, and did a lot of work with interactive graphics, computer vision, telepresence, and sensors, and sensor optimization, and motion planning of different actors within some of these visual systems and simulations. So I carried that work into research with Kennedy Space Center and did simulations of the shuttle's trajectory. And so did a lot of work in that space. But then shortly after that, I got the startup bug, and I worked at a startup that was acquired by MySpace. So that lets you know how far back that goes. And during this time, social media was very new and all the buzz. And so there was a lot of exploration with what does this mean for how we communicate. And this was also the time of very interesting and impactful progressive movements. So things like the Arab Spring started during this time. Shortly after this period of the early days of social media, we have things like the Black Lives Matter movement 1.0, and we have things like the Me Too movement. And the Occupy movement. And also, I had used social media to build communities from the ground up. Things like Women Who Code Atlanta, things like Refactor Tech. And so I saw firsthand how social media could be this tool for good, this tool for progressing society. And very early on, I didn't see a lot of the harms that we may now understand can come from social media. And so at the time, I saw it as this kind of net positive influence on how we interact with each other. And then fast forward to 2012, and I was doing a lot of mobile development and IoT, kind of getting back to some of that sensor work that I had already done. And this really brought a time of hyper connectivity. So this connectedness that's very natural for us now was just getting started with smartphones and wearables and home devices that were always connected. But there's a lot of sensor data, and there's a lot of personally identifiable data that comes with that. And there's a lot of storage and power concerns that I had to be concerned with. So this was probably the first time in my career that I started to become aware of the external impacts that we have on society with this constant sending of personal data and the need to protect that, and also power consumption and concerns around that. And then moving to 2019 through 2022 was a really unique time because I got to come back to mixed reality. So coming full circle there. But this was also during the prime time of the pandemic. And so it was a time where people were looking for different ways to connect and to build deeper, tighter integrations because they were separated, because we couldn't communicate and connect in the ways that we were used to. And so this was a really interesting time to be building in this space and taking some of the things I learned from mixed reality, telepresence, sensors, and bringing that here made a lot of sense. So it really did feel like I was building for the time. I also became aware of, again, building on that connectivity, the hyperconnectivity, the sensor work, and having all of this data, again, personally identifiable data. And when you're talking about XR, especially modern XR, there are a lot of ways that you can share this information without folks knowing exactly how personal this information is, how private this information should be, how widely spread it's being shared. We see a lot of augmented reality, computer vision, surveillance research, and solutions being shared at the time. Like anytime you go to an airport, for instance, and they scan your face instead of you having to pull out your passport or your license, like these kinds of technologies are sending a lot over networks, and we don't always understand what's being sent with that. And so this was a time of increased awareness on my part of the kind of data that's being shared, and also digging more deeply into energy and how this affects the environment. So bridging from the metaverse to, say, the blockchain NFT buzz that was happening around the same time, we're understanding the vast environmental load that NFTs and data mining and all of this can have on the environment. I'm really excited about these technologies, but I'm wanting to mitigate some of the risk I see. And I'm also noticing that this is leaps and bounds above the impacts that we were seeing with previous emerging technologies. Fast forward to shortly after this kind of metaverse buzz, we move right into the Gen AI buzz and huge large language models that require lots of space, lots of energy, and billions of parameters. And honestly, tens of billions of parameters. And we aren't really thinking again about the ways that this is affecting society. We just open up this Pandora's box of an emerging technology, as we tend to do, and we don't understand the impacts on the environment and on society. And we can see some of these already with Sora just being released and OpenAI already having to pause any video that contains Martin Luther King because his family is very concerned about videos being used to say things he didn't say and to diminish his legacy and diminish his work because of the realism of these AI generated videos. And so there's a lot of space to improve our awareness of what these emerging technologies call for from each other and from the environment. And so I want to start by digging into some of these big problems with big AI. Then I'll get into some of what I find to be the most interesting stuff, the rise of small local AI. I'll tie it back to real world benefits for performance, privacy, and the planet. Then I'll walk through the open source toolbox you can use today and talk about some of the really powerful ways to build with them and where we can go from here with small local AI. So let's dig into the world most of us are living in right now. We've all played with these huge proprietary AI models, and they're super convenient, but that convenience comes with a pretty serious cost. And what starts out as a simple, easy API call can really quickly spiral into a tangled mess of subscriptions and dependencies that you have very little control over. And then you start to understand the price tag that comes with that convenience. And these costs can balloon like crazy without any warning. But an even bigger issue, honestly, is the privacy risk. Regulators are already cracking down on apps because sensitive user data, sometimes even our own API keys and code, is being shipped off to third-party servers. And on top of that, you're stuck with vendor lock-in and these content filters that you have absolutely no say over. And then there are the very real environmental concerns as an increasing number of data centers pop up in a community near you, disturbing water and ecosystems, and as a completely fair exchange, handing us skyrocketing energy costs for our troubles. By the way, if you're in Georgia, where I am, and you happen to watch this on or before November 4th, don't forget to vote on open seats in the Public Service Commission. The Public Service Commission decides, for example, whether Georgia Power can increase rates on us. And with multiple data centers in the works across the state, this is a really important time to make your voice heard. So getting back to it, we're talking huge financial, privacy, environmental, and personal energy costs. But what if there's another way? There's what I think is a really cool, powerful movement happening, and it's all about smaller open source models that are designed to be specialist, models that you can run wherever you want, even right on your own laptop. And so what is a small language model, or SLM? We can think of it as a really compact, super efficient model, usually anything under about 10 billion parameters. And the whole point is that they're designed to punch way above their weight class while running on hardware you already have. And when we talk about that kind of hardware, we're talking servers, edge devices, even your phone. It's really fascinating that there's this total shift in philosophy with this movement. You have these huge, large language models, but they are generalist. They know a little bit about everything. SLMs, on the other hand, are specialist. You can fine-tune them on your specific high-quality data, and they can actually outperform the large models on those specific tasks. It's a move away from bigger is always better to a much smarter, right-sized AI approach. And if we think about how fast this is all moving, not long ago, getting a competent generalist level performance meant you needed a massive 65 billion parameter model. And in just about a year, we've seen that shrink all the way down to models under 3 billion parameters. We're literally learning how to pack incredible power in smaller and smaller packages. So you might be thinking, this sounds really cool, but how do I use it? The open source community has been on fire, building an entire ecosystem of amazing tools that make building with SLMs something any one of us can do right now. And it brings me back to my whole motivation for digging into all of this in the first place. It's about finding a balance, because choosing to build with small local models isn't just a technical preference. It has huge positive real-world impacts. First, thinking through performance is much faster because you're not waiting on a call to some data center halfway across the world. Your responses can be significantly quicker. This unlocks the ability to build truly real-time interactive apps that feel snappy and responsive. Next, if we look at privacy, when you run your model locally, your data stays local. Your user-sensitive information your company's secret sauce, or your API keys, none of it ever leaves your control. You completely sidestep this massive security and privacy landmine that's just built into the cloud. And finally, let's think through the benefits for the planet. The environmental math on this is a bit complex, and there are trade-offs, like the potential for more waste in certain circumstances. But a decentralized, smaller AI approach offers a really compelling path forward. You're drastically cutting down on the energy-sucking process of transmitting data constantly, and we're shifting the workload away from these giant, power-hungry data centers. The potential for a smaller carbon footprint is absolutely there. And so this sounds good, but when we put this all together, what does it mean for us as developers and researchers? Running an SLM on your own computer is a surprisingly accessible first step for any aspiring AI developer or hobbyist. And the open source community has been building and growing a whole range of tools to get you started. By setting up a local SLM, you gain complete control over your data, avoid subscription fees and vendor lock-in, and open up an incredible opportunity to learn by experimenting with the same kind of technology that powers the biggest names in AI. So what is a local SLM? A local SLM is a small language model that runs entirely on your own computer, your laptop or your desktop, instead of a powerful server in the cloud by a company like OpenAI or Google. Unlike services such as ChatGPT that you access through a web browser, a local SLM operates completely within your own hardware, eliminating the need to send any data over the internet. This self-contained approach brings a really powerful combination of benefits that are a huge boost to learning, development, and privacy-conscious work. If we think about privacy and security, since the model and your data never leave your machine, you maintain absolute control over sensitive information. There's no need to worry about your prompts or documents being stored or used by a third-party provider, making it the perfect solution for working with private data. It's cost-effective. Cloud-based AI services often come with recurring cost, either through subscription fees or usage-based pricing for API calls. Local SLMs eliminate these expenses. Once you have the necessary hardware, the primary costs are electricity, making it a highly budget-friendly way to experiment and build, especially for high-volume specific use. Then there's the freedom to customize, personalize, and learn. The world of open source AI is vast and growing daily. Running models locally gives you the freedom to download, modify, fine-tune a wide range of models to fit your specific needs. This hands-on experience provides a much deeper understanding of how AI models work, turning your computer into a personal AI laboratory. I don't know how many of you are like me, but I love the data around my health and biometrics, and I'm a little wary of sending that data over the cloud and relying on large companies to keep that data private. And I want to be able to experiment in that space, but that concern around privacy has made me pull back in recent years. But with my own SLM, I can start to capture my data in different ways, and that information never has to leave my local device. So that's a very personalized usage of this kind of system. And then there's the reduced environmental impact. Because you're not sending repeated calls to one of the big tech servers, you're not contributing to the demand for huge invasive data centers. And because SLMs can be more efficient than LLMs for a very specific task, your personal energy usage will also be optimized. A relatively modern laptop or computer is often all you need to begin experimenting. While not strictly required, a dedicated graphics card, GPU, is highly recommended. GPUs contain specialized memory called VRAM, video random access memory, which is crucial for handling the massive calculations that LLMs perform. The more RAM you have, the larger and more powerful the models you can run smoothly. However, many excellent smaller models are designed to run on consumer cards with as little as 4 to 5 gigs of RAM. But if you want to run a larger model than your GPU's RAM can handle, this is where a powerful feature called CPU offloading comes in. Tools built on the llama.cpp library can split the model between your fast GPU RAM and your computer's main system. A GPU with only 12 gigs of RAM could run a 45 billion parameter model, by loading most of it into RAM and offloading the rest to be handled by the CPU and system RAM. The trade-off is a decrease in speed, but it makes larger models much more accessible on less powerful hardware, which is a game changer for hobbyists on a budget. And you don't need to be a machine learning expert to manage SLMs. User-friendly hardware software tools, often called runners or servers, handle all the complexity for you. They download, manage, and run the models, providing a simple way to interact with them. Here are two of the most popular and beginner-friendly options. Ollama, which is what I have used in my experimentation. It's a pretty straightforward command line-based tool that makes downloading and running SLMs incredibly easy. It's an excellent starting point for anyone comfortable with the terminal. If you prefer a more visual experience, Llama can be paired with GUIs like OpenWeb UI to help give you a private ChatGPT-like web interface for your local models. I've heard good things about LM Studio, but I have not used it yet. But it's an all-in-one desktop application with a user-friendly GUI. It features a built-in Hugging Face model browser, which makes discovering and downloading models much easier. It also provides helpful quality of life information that tells you if your computer has enough resources to run a specific model, making it a fantastic choice, again, if you prefer a visual point-and-click experience. The final ingredient is the AI model itself. And thanks to the open source community, thousands of powerful models are available for free. The most popular repository for discovering and downloading these is Hugging Face. For beginners, it's best to start with the smaller general-purpose model, and these models are efficient and well-regarded. Here are a few choices. The Llama 3 family from Meta is a highly capable series of models known for strong reasoning and general text generation abilities. They are a popular baseline for many tasks. Then there's Mistral 7B, an incredibly popular and efficient model that offers a fantastic balance of performance and size, making it a favorite in the open source community. Also, one of the few here that is not necessarily supported or sponsored by a big tech company. These are all great starting points for general tasks, but as you advance, you'll discover a vast ecosystem of specialized open source models fine-tuned for specific domains, such as coding. A lot of folks like to use DeepSeek, Coder V2, mathematical reasoning, Mastral, and even understanding images with other vision models. You might be wondering how these massive multi-billion parameter models can possibly run on a laptop. The answer lies in a clever technique we'll talk about in a little bit. But first, let's get into how we can have our first conversation with our local SLM. So I recommend getting started with Ollama because, again, it's what I've used and it got me started pretty quickly without too much fuss. And so I've listed the steps here to download a model and have your first AI-powered chat. First, you're going to install Ollama from the Ollama website and download the installer for your operating system. There are installers for macOS, Windows, and Linux. Then open your terminal on macOS or Linux, just your usual terminal app. On Windows, I would suggest PowerShell versus the command line prompt. And then you'll download your first model, maybe try 5.4 mini. And then you're going to type the following command into your terminal and press enter, Ollama run 5.4-mini. This tells Ollama to connect to its library, find the quantized 5.4 mini model, and download it to your computer. Then you can chat with your model as you would chat with any GPT. And then when you're ready to exit, you can simply type bye. And so now we know how to get started, but what are some of the workflows and applications that SLMs open up for us? So one of the things that a lot of folks do pretty early on is give our models long-term memory with RAG. RAG is retrieval augmented generation, and it's a technique that lets you connect an SLM to your own documents and data. Instead of relying only on its pre-trained knowledge, the model can retrieve relevant information from your files to answer questions. This is how you chat with your documents, allowing you to build a private knowledge-based assistant that can answer questions about your PDFs, your notes, or your code repositories. A really cool talk that I attended from a friend at All Things Open was about creating kind of an open source version of herself, right? So she had this knowledge base of social media posts across multiple platforms, SMS messages, all kinds of data from various periods of her life that she could use to start to query and prompt and understand. And so it was very much a way of open sourcing herself, but having that be really private and based again on these documents and messages that she's contributing to it. You can also give your model tools with agentic AI. So beyond accessing data, what if your AI could perform actions? This is the core idea behind agentic AI, giving models tools to interact with the world. Both Olama and LM Studio expose a local AI, which acts as a bridge between the model and other software. This API is the mechanism for building agents. It allows you to programmatically give the SLM access to tools, which can be anything from a Python function to query a database or check your calendar, an external API to fetch real-time weather or stock information, workflow and visual builder that acts as an integration layer to connect your AI to hundreds of apps. One really good talk that I've seen is Angie Jones. She does a talk that compares agentic AI to the mashups of the early 2000s. And it's a great way to rethink how you can build this kind of distributed, decentralized experience with agents. By giving an SLM access to these tools, you can create autonomous agents that reason, plan, execute multi-step tasks. This is the foundation for advanced AI systems built on agentic frameworks like Crew AI and AutoGen. And this is actually something I haven't tried yet, but I'm really interested in trying. So it's this hybrid approach to prototyping with LLMs and SLMs. And so one thing I have learned through my interaction with LLMs is that they're great because of their generalist nature. They're really great at discovery. And so starting here with an initial large language model and doing some discovery, starting with some early prompts, and then measuring the performance around that, measuring how users are going to interact with an LLM in this way, and then refining those prompts, getting those prompts more narrow and a little bit more specific, and then bringing in an SLM that you can fine tune and train on smaller, more specialized data. And then deploying with the SLM instead of deploying with the LLM will allow you to save costs and reap the benefits that we've been talking about in this whole presentation. So that kind of hybrid approach, allowing you to bring in the best of both worlds from LLMs and SLMs. So if you were new to this and you follow the steps here, then you will have taken your first major step into the world of applied AI. And by running a small language model locally, you now have the power to learn, build, and experiment in a completely private and secure environment. You've broken free from the constraints of subscription fees, data privacy concerns, and vendor lock-in that come with cloud-based services. And this can be your personal AI sandbox, where you have full control and endless possibilities to build truly intelligent systems. So go ahead, explore the vast universe of open source models and build something amazing, and continue your journey of learning and creation. All this means the future of AI innovation is becoming more accessible, way more secure, and a whole lot more responsible. It's a future that's moving out of the cloud and back into your own hands. So to wrap things up, building with open source SLMs gives you total ownership. You control your model, your data, your destiny. It unlocks a level of customization and personalization that lets you get incredible performance for specific tasks. It makes powerful AI accessible to everyone, not just big tech. And most importantly, it lets you be a responsible developer, building with privacy, performance, and sustainability in mind. Right from day one, this whole shift is putting an incredible amount of power back where it belongs in the hands of developers. It's a move towards building systems that are not just intelligent, but also trustworthy and sustainable. The tools are here, the models are ready and waiting, and the community is absolutely thriving. So the only real question left is, what are you going to build with it? So these are a few talks around the small AI space that happened at All Things Open. The first one is that talk I mentioned from Liv Erickson around the own algorithm open sourcing myself. Everything you need to know about running LLMs locally is a really hands-on guide to building out your local SLM tech stack. When smaller is better, using small language models to power big ideas by Don Shin. This is great if you're trying to figure out where it makes sense to use LLMs versus SLMs. And then this talk here your open source SLM Toolbox built for performance, privacy, and the planet by yours truly was not recorded, but that's the reason for this. And several of these other talks were recorded. And so once those recordings are out, I'm happy to share so that we can all compare notes. And then if you want some deeper learning, there is a small data and AI conference happening again. If you see this before November 4th, that's happening in San Francisco. And it has 2 days of talks delving into what we talked about here in about 30 minutes, a wealth of information around the small AI space. And then I mentioned early on that I've been fascinated by this kind of co-evolution between these emerging technologies and society. And You, the Machine is a really interesting book about how the author sees AI as a reflection of us and what does that mean about what we build. And if you're interested in this intersection between tech and society and how we all can think about how and what we build, please tune into my newsletter, Code and Conscience, where I talk about AI and more, and would love to see you and answer some of your questions there. And again, these are the ways that you can connect with me. There's my website. There are all the social media platforms that I'm on. Thank you so much for your time. And please let me know what you all decide to build with your local open SLMs. Thanks, everyone.